Now let's see what our feature engineering component will do. We've already created a data ingestion and validation component as part of our training pipeline. Our component will read the data from data lake from the location where we have kept our validated data. It will do the feature engineering and store the feature engineered data back to our data lake. Let's see how can we create this component. Let's now look at how will we create a second component, which is our feature engineering component. So I'll create a new folder over here and let's call it feature engineering. And just like what we did with our data validation component, we had a conda.yaml file. I'll also create a conda.yaml file for this particular component. Let me list down the dependencies here. So we are deliberately creating a different conda.yaml file for each of the components so that we understand when we run this training pipeline again, what were the software dependencies. Let me close it. Now I will create a run.py file. And this is going to be my main file. Let me copy it inside this folder. So now run.py is part of the feature engineering component. Let's see what our feature engineering component is supposed to do. So it's supposed to take data from the landing zone where our data validation component has parked the data and then do feature engineering on it and save it in a feature store. So just to remind ourselves where exactly the data is parked. So for the feature engineering component, this is where the data is. So we will take our train.py file from here. And then we have a feature store. And we will do our feature engineering and store our data in the form of numpy arrays over here. This is what our feature engineering component is supposed to do. Let us now see what kind of feature engineering we are looking at. Now, the original notebook which was given to us based on which we are creating our training pipeline. The only thing that we are doing is we are breaking our data into an X array and a Y array. And these features are then used in our training task downstream. So our feature engineering component should take data from the landing zone and break it down into X and Y numpy arrays and store it to a feature store. So let us see how will we do that. Let me first get the dependencies and the imports that I'll need to do. So you can now recognize most of the imports that we are doing. rparse will be for creating command line arguments for this particular component. Logging would be to log intermediate outputs so that we know in what state of execution our program is in. Pandas will be used to pull in data from our landing zone. Now you see these two new imports, which is pickle and s3fs. These are needed because we will need to write back numpy arrays to our S3 drive. So before we discuss how will we write the numpy arrays back to our S3 drive, let's create our command line arguments. Now we'll need two command line arguments. One would be the path to our train data, and this will be the path to the train data which has been validated by our previous component. Second will be the path to our feature store on our S3 drive. Let's now see how will we load our numpy arrays to S3. We will make use of this function. So the import that we did, which is S3 file system, it helps us to treat our S3 drive as a normal file system and perform normal open and write directives on our S3 drive. So this is what I will use to write my numpy array onto the S3 drive. Let's look at our main function. So you can see we are initially reading our data from the validated train path, which we'll get from our command line arguments. Then we are dropping two columns and creating an X matrix and finally we are creating a Y array, and then we are using this function load S3 to write our data back to the S3 drive, particularly the place on the S3 drive where we want to store our features. And after this is done, we are done in terms of feature engineering. Let's complete this script by calling the main function. We'll finally call our main function, and that will do the relevant stuff for us. Now to run this particular component, let's see what are the commands we'll need to use. So we'll go back to a repository which we've created, and this is what I'll need to do. I'll need to change my directory to the feature engineering folder, activate the feature engineering Anaconda environment that I must have created, and then run my run.py file with the relevant arguments. So let me do that. Let's go to our feature engineering directory. Let's do conda activate feature engineering. So it activates the right Anaconda environment for me, and finally I run my Python command. Let me hit enter, and hopefully if we've done everything correctly, this should work. I think I didn't save this file. Let me save it and now try to run. So you can see at the end of execution, our logger tells us that the data has been saved after doing the feature engineering. Let's verify. Let's go to our S3 drive and let's refresh this. And you can see the time is 1:05 and this is at 1:04. These two numpy arrays are written over here. So this concludes our discussion on how to create a feature engineering component. I hope you are finding a pattern over here. For each component, we are necessarily creating a conda.yml file, and then we are necessarily creating a main script that as of now is accepting command line arguments. But as we build this pipeline further, we will look at how to get rid of manually providing command line arguments, but that's something that we'll probably discuss a couple of videos down the line. And in case you're wondering where the GitHub repository is, I will be providing the links to the GitHub repository in the description in this video below.